All right, today class we're going to go through linear and quadratic functions, and we're just going to start with the general polynomial function. All right, so general polynomial function follows that f of x is equal to a of the leading coefficient x to the n power, and then we just go, we got another exponential x to the n minus 1, all the way down until you get the squares, the linear term, and a constant at the end, and that's a sub 0. That's just ordering, and we'll get more into this later. All our exponents are non-negative integers, so nothing that x is raised to will be negative. And also all our coefficients are real numbers, so a of n, a n's minus 1, a2, a1, those are all going to be numbers that we can deal with, even square roots, as long as they're real numbers, no imaginary. And the n equals the degree, so whatever that is, whatever our highest power is, that is the degree. And then a sub n is our leading coefficient. Whatever the number is in front of the highest power is our leading coefficient. But we also have coefficients for each and every term. So that is what makes up a polynomial, all right, or polynomial in general. So looking at this, right, we can determine if the function is a polynomial function. If so, state what degree in the leading coefficient. If not, explain why not. So if we look at the first one here, 4x cubed minus 5x minus 1/2, we will see that none of these, all our exponents are non-negative. So, and, nothing is, everything's a real number. So, knowing this is a function, we see, yes, it is. And our degree is our highest exponent, so in this case it's 3. And our leading coefficient, I'm just going to put LC for that, is whatever's in front of that, it is 4. So degree x is 3, degree is 3, and the leading coefficient is 4. Let's look at B. G of x equals 6x to the negative 4 plus 7. Well, right there off the bat, we see we have a negative exponent, so no, and we have a negative exponent. So that right there tells us it is not a polynomial function. Negative exponent. Looking at C, right? H of x equals the square root of 9x to the 4th plus 16x squared. Well, you think, oh, if I take, no. Because if you think about it, guys, that's just 9x to the 4th plus 16x squared raised to the 1/2. So that's a no again, and that is a fractional exponent. Remember, we have to have a whole number, basically powers to 0 and above. Nothing as a fraction. X. Oops, X. And D here, k of x equals 15x minus 2x to the 4th. That is a yes. All my exponents are whole numbers. And our highest power is x to the 4th, so my degree is 4. And my leading coefficient is the number in front of x to the 4th, which is negative 2. So remember, minuses or negatives out front will also give us that. All right, so let's look at linear functions. All right, linear function is a function in the first degree. All right, commonly y'all seen it as y equals mx plus b. X, first degree. Ax plus b as a function form of f of x. All right, so write an equation for the linear function of f such that f of negative 1 equals 2 and f of 3 equals negative 2. Guys, right here, if you do not remember, f of negative 1 is your x. That's x of 1. The 2 is your y, which is 1. F of 3 is x sub 2. Y negative 2, or negative 2 is y sub 2. So again, first thing we need to find, as always, is our slope. So slope is y2 minus y1 over x2 minus x1. And so to solve in this case, negative 2 minus 2 over 3 minus the minus 1. So in their case here equals negative 4 over 4, which is negative 1. And then of course, to get the equation of this line, we want to put it in point slope form. So knowing that, that is y minus y1 equals m times x minus x1. And again, we can use either point for y1 or x1. I'm just going to use negative 1, 2, and just use that one. So y minus y1, which is 2, equals negative 1, my slope, times x minus 1, which ends up being plus 1. All right, and then we just solve for y. Y minus 2 equals negative x minus 1. And then bring the 2 over, y equals negative x plus 1. And so there is my linear equation. Pretty simple. Hopefully everyone remembers that from Algebra 1. And we move on. Alright, so now we talk about quadratics. Quadratic, functions that are in the degree of 2. Standard form of a quadratic, as we see before, is y equals, or f of x equals ax squared plus bx plus c. Vertex form, which you guys learned last year and been using a lot, or should be using a lot, is f of x equals a times x minus h squared plus k. Again, now with this, a is our stretch factor, how much up and down, or how quickly we can go up and down. A positive a opens up, and negative a opens down. So open up, u up, u up, negative a, open down, u going down. Alright. If the absolute value of a is less than 1, then the graph is wider, so it gets really wide. That's kind of a smush, or get wider. And if absolute value of a is greater than 1, then the graph is narrower. It gets thinner and thinner. And so we see we have this thing here between negative 1 and 1. It gets really wide, so our fractions like 1/2, 1/5, all those things, negative 1/2, 1/5, all those things in there. And then again, anything above 1, narrow, gets really, really tiny. It gets up and down a lot faster. And h and k are the coordinates of my vertex. Change sign of h. Just make sure we do that. Change the sign of h. So if you look back in our equation, x minus h squared, remember h is the opposite when we're talking about it in coordinates. And then your axis of symmetry is x equals h. Whatever my value of h, our axis of symmetry, again, that is where our parabola here is even on both sides. And then, of course, we have our third form, intercept form, a times x minus p, x minus q, where p and q are your x-intercepts. You should all remember that from last year. All right, so dealing with examples of this, write the equation of quadratic function in vertex form and graph the function. All right, so first off, as we do this, we want to replace f of x with y and write in decreasing degree. So in this case, it's already written in decreasing, x squared minus 4x plus 6, in this case y. Now, we need to put it in vertex form, which means we need to get the x squareds and all that stuff in something we can actually factor out nicely. We want to make it a perfect square trinomial, which means, in this guys, we are going to do completing the square. So if you remember that, first thing we need to do is get the x squared and the x by itself. So we're going to move the 6 over. So move the constant, we're going to subtract 6, so y minus 6 equals x squared minus 4x. All right? Then, you're factoring out an a if possible. We do not have one here. It is 1, so we don't actually have to do this, so we're going to skip that step. And then we're going to complete the square. We're going to take whatever our b value is, and we're going to divide it by 2 and square it. And add that to both the parentheses and add it to a b squared to the left side and the right side. So whatever we do, we're going to add one to the other. All right, so in our case here, we have y minus 6, and we're going to add some value equal to x squared minus 4x plus some value. So if we think about it, b here is negative 4. We take half of negative 4, it's negative 2, and we square it. And that gives me 4. So we're going to add 4 there. And since there's nothing multiplying the right side by it, we add 4 to both sides. All right? So at that point, we can simplify. And we end up with y minus 2 equals x minus 2 squared. All right? We just took negative 6 plus 4, and then we condensed or factored down the right-hand side because it's perfect square triangle. All right, at this point, we can now move the 2 back over, or move the constant back over, and we get y equals x minus 2 squared plus 2, and if you rewrite it in function form, f of x equals x minus 2 squared plus 2. We'll pretty much jump to that from now on. And then, of course, we can graph this now. We know that, hey, our function moves over 2 to the right and up 2, so 2 to the right, up 2. There's my vertex. And then, of course, since it's a parabola and there's no stretch factor, we know it's 1 by 1 on both sides, and then 2 by 4. 2 and 1, 2, 3, 4, 2 and 4, and then my parabola is like this. And I want you to kind of remember this from last year. So let's do another one here. Alright, so we have f of x equals 10 minus 16x minus x squared. Alright, so we rewrite this in descending order. So y equals negative x squared minus 16x plus 10. Alright, move the constant over. So y minus 10 equals negative x squared minus 16x. We want to factor out an a. In this case, we do have 1. It is negative 1. So x squared plus 16x. Alright, so now we're going to do our addition. So we're going to add a number to both sides. Negative 1 times x squared plus 16x plus something. And we do this, we take half of 16, which ends up being 8. And we're going to square the 8, which ends up being 64. But we're not just adding 64, we're actually subtracting it, because you see 64 times a is minus 64, so we're actually going to add a negative 64 to the left side. So, given that, we can now condense or simplify. We get y minus 74 on the left equals negative 1 times x plus 8 squared. And then we can now take that and write our function as y equals negative 1 times x plus 8 squared plus 74. And then, of course, we can write that instead. We should write it as f of x. F of x equals. So you can just put negative or negative 1 in front. That's fine. And to graph it, all right, we are at minus 8 plus 74. So that should be somewhere right about there. All right. And if you get it, of course, you know, at 10 and 16 would be 10. If you look back at the original, if you go back to the original equation, the reason I can do 10 is my y-intercept, because in the original, 10 is my y-intercept, it's the constant. So knowing that my vertex is 8, 8, 10, and if you think about it, 8 to the right, it's 64 because you're squaring. So 64 and 64, so 8 and 8. So I just give a rough estimate of where the 16 was, but we know it crosses at 10. All right, let's move on to the next one here. All right, we got f of x equals 2x squared plus 6x plus 7. All right, rewrite it. Y equals 2x squared plus 6x plus 7. Move the constant over. Y minus 7 equals 2x squared plus 6x. Factor out an a. So y minus 7 equals, we see both of them share 2, so x squared plus 3x. And now, we're going to find our value. So y minus 7 plus blank equals 2 times x squared plus 3x plus blank. Alright, so we need to take half of b, which is 3, so it's 3 over 2, and we're going to square it. So 3 over 2 squared gives me 9 over 4. So I'm going to add 9 over 4 over on the right. But on the left, it's not that I'm just adding 9 over 4. I'm doubling that because it's 2 times 9 over 4, which ends up being 9 over 2. Or 2 times 9 over 4. 2 times 9 over 4, 1, 2. All right, at that point, we want to add like terms. So I'm going to convert the 7 to minus 14 over 2 plus 9 over 2 equals 2 times x squared plus 3x plus 9 over 4. So on the left-hand side, we get y minus 5 over 2 equals 2 times x plus 3 over 2 squared. And then now we can rewrite our function. Oops, I should have moved that down, sorry. There we go. So now we can rewrite our function as f of x equals 2 times x plus 3 over 2 squared plus 5 halves. So where's my vertex in this? Well, my vertex is at negative 3 over 2 and 5 halves. Or if you want to do it, negative 1.5 and 2.5. So negative 1.5, 2.5 puts me pretty much right smack there. And we do have a stretch factor of 2 now. Instead of being 1 by 1, it's 1 by 2. So we should be there, 1 by 2. And then if you did 2, 1, 2, you should be up by, instead of 4, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm just off the grid. So basically, there and there. So give at least 2 or 3 points and we are golden at that point. And again, you should see we cross right at 7 at 1.5, so you should pretty much 1.5 cross right there. Again, feel free to pause this thing at any time to make sure you're doing this right. All right, so we're going to write the quadratic equation and intercept or factor form, find the zeros, sketch the graph using the intercept. All right, so looking at A here, we have x squared minus 7x plus 12. So we got to factor it. So f of x equals, factor it, values that multiply to be 12 add up to negative 7 are x minus 3 and minus 4. So if we find my zeros, we know they're at 3 and 4. So if we plot them on the graph, 3, 4, we know the parabola is going up, so something like that. So that's the rough sketch at this point. All right, let's look at B here. 2x squared plus 4x minus 5. All right, we're going to factor that one. Now we have something up front, so if you need to do guess and check. Factors of negative 5 multiplied by 2 will give me positive 4. So we know the first ones are going to be 2x and x. So if you do not remember, factors of 5 are 1 and 5. So it's pretty obvious that one of these is going to be 1, one of these is going to be 5. So if I choose 5 there and 1 there, 2 times 1 is 2, 5 times 1 is 5, and it wouldn't work out. This should actually say 3x, and that would work at this point. So sorry about that. It should be 3x. So go ahead and change that if it's not already changed on your paper. So just to get something nice, it's minus 1 plus 5 because 5 minus 2 is 3. So that would make our zeros here negative 5 over 2 and positive 1, which is negative 2.5, positive 1. And so our graph roughly does something like this. All right, let's look at C here. 9 minus 4x squared. That should be easy. It is a difference of perfect squares, which we all love and hide. A plus b, a minus b, or 3 plus 2x times 3 minus 2x. Factors of 9, square root of 9, square root of 2x, 4x squared. So our zeros in this case are negative 3 over 2 and 3 over 2. So when we graph this, -3/2 or -1.5, +1.5, and you actually know your y-intercept real quickly, it is 9. So it does something like this. Pretty straight up and down, pretty quickly. That stretch factor of 4 does carry a bit. Alright. So now, we can do it with both vertex form, we do it in vector form. What happens when we give you the graph and we ask you to find us the function itself? So, we're going to write the equation for the quadratic function shown, given the vertex and the point indicated. Alright, so we want this in vertex form. So remember, vertex form is y equals a times x minus h squared plus k. Now, we have the vertex. Here's our h, here's our k. If you think about it, the 1 and 5, that's a y, or that's an x and that's a y. That's going to help us when we need to find a. So, we can plug our values in here. So, we got y equals a times x plus 1 squared plus k, which is minus 3, -3. Now, since we have hk and we know an x and y, we can plug x and y in. So we're plugging that in, we get 5 equals a times 1 plus 1 squared minus 3. And now we can just solve for a. 5 equals a times 2 squared minus 3. 5 equals 4a minus 3. 8 equals 4a. 2 equals a. So now that I got a, I can then rewrite my equation now because I know a, I know what I need for h and k, so I get y equals 2 times x plus 1 squared minus 3. There is my equation. Let's take a look at the next one. They give us my vertex. It's 111. Point on the quadratic is 4, -7. So there's my h, there's my k, that's an x, and that's a y. We're going to plug it into y equals a times x minus h squared plus k. Start filling in the blanks. Y equals a times x minus 1 squared plus 11. It's plugging in h and k. Now we can plug in x and y. -7 equals a times 4 minus 1 squared plus 11. So -7 equals a times 3 squared plus 11. -7 equals 9a plus 11. -18 equals 9a. A equals -2. And it's pretty obvious we're going down, so it definitely better be negative. It makes sense. Alright, at that point we can then rewrite our equation. Y equals -2 times x minus 1 squared plus 11. There is my quadratic equation. Hopefully all this is coming back to you. You saw this last year. Make do with it as we go along. Alright. Let's ramp it up a little bit more here. Write the equation of a quadratic function passing through the points 1, 6, 2, 5, and 3, 2. Alright, so this is a little bit more difficult here because we got to figure out what's going on. Alright, now let's just go back standard form. So this is what we're going to have to do. Y equals a x squared plus bx plus c. Because we have 3 different points, it's going to take us a little bit of time. So we got to be careful with all this to figure out what's going on. Alright, so let's start out here. Let's start plugging in numbers for, let's just take the first point. That's an x and that's a y, right? So we can plug it in. We get 6 equals a times 1 squared plus b times 1 plus c. Which gives us 6 equals a plus b plus c. Alright, so we're going to stick with that. That's our first equation. Let's find the second equation here. Again, x, y. We're going to do this one in green. So So here we got 5 equals a times 2 squared plus b times 2 plus c. So that gives me 5 equals 4a plus 2b plus c. So you see now, hey, what do I have? What do you think I'm starting to do here? I'm starting to get a system of equations, right? I have ABCs, right? So think about, what can we do? We can start getting rid of certain things here, yes? All right. So a good thing to do here would be, we can eliminate one of our variables real quickly knowing we have the first equation, second equation. If we subtract the first from the second, negative 6 minus a minus b minus c, we see that we eliminate, we get negative 1 equals 3a plus b, and my c's go away. So now I've eliminated one of my variables. All right, I can solve 2. 2 is a little bit easier than 3. All right, so we just now got to figure out this. So this is where we need the third equation. All right, plug in the third one. Here's x, here's y. I'm going to go this one in blue. 2 equals a times 3 cubed, or 3 squared, plus b times 3 plus c. So we get 2 equals 9a plus 3b plus c. And if we think about it, I can do something with this one. I can use one of my other 2 equations to get rid of it. I'm going to use the second equation to eliminate the third one here. All right? I'm going to subtract minus 5 minus 4a minus 2b minus c. Just get rid of it. All right? And the reason I'm doing that is because I took the first equation to do the second one. I'm going to take the second one to do the third one, so these two we're not overlapping at any point. And so we get negative 3 equals 5a plus b, and then the c's cancel out. Now look at this. I have 2 separate equations. Both of them, right? I've now eliminated my c's. I have a's and b's. I can do this. I can solve for this because I know how to do a system equation with 2 variables. So what I'm going to do is, hey, I got one equation. They both have a single b. I'm going to do elimination. I'm going to subtract the second one here to the first one, and I'm going to get plus 1 equals negative 3a minus b. When I do that, my b's cancel out. I get negative 2 equals 2a. Look at that. Divided by 2, negative 1 equals a. All right, so I have negative 1 equals a. Hey, take that. Let's plug it into that one right there. We do this. Plug it in there. Negative 1 equals 3 times negative 1 plus b. Negative 1 equals negative 3 plus b. B is equal to 2. Oh, man, look at that. I got that one. I have a. I have b. Now what can I find? Well, looky there. 6 is equal to a plus b plus c. I know a. I know b. I know what it's supposed to end up as. Let's plug it into that one. 6 equals negative 1 plus 2 plus c. 6 equals 1 plus c. C is equal to 5. So, I have c, I have a, I have b. We can write our equation now as y equals negative x squared plus 2x plus 5. I found my a, b, and c. I know this is a lot of work. This is probably the toughest thing we're doing. But guys, if you can manage this one, you can accomplish anything in this section. So again, set up to the system. Go with the first equation, plug in x and y. Do a second equation, do a third equation. Think, all right, first equation. Can I do something to the second equation, take something out? Yeah, I got rid of c. Do the same thing to the third equation with the second equation. Eliminate it. Same variable that you did in the first equation. So this time you saw I eliminated c in both of them. And it ends up where I get a system where I can now solve for a and b. And then I can do systems again from those two I solved for, figured out, and get one variable. Solve that one variable, plug it back into the other one. Solve for that one. Take both of these, put it back into one of our originals, solve for c. And again, you don't have to do everything the way I did it. You can still plug them in. The other things, you'll still get it right as long as you're doing it correctly. All right? So take your time, think through this and formulate it. I am going to move on, but if you need to, pause, then think. All right. Vertical free fall here. All right. Vertical free fall. You may have seen this, especially if you take physics. A little bit different, but basically this is the same formula. All right. So vertical free fall, we have basically, for a vertical free fall, S of t equals negative 1/2 g t squared plus b of 0t plus s of 0. And v of t is negative gt plus v of 0. All right, so what are these each of? Well, s is the height of an object in free fall. So wherever the object, so the first equation tells us what is the height of any object, tennis ball, baseball, whatever, a bowling ball, at any point based on time. V is our vertical velocity of an object in free fall. So v of 0 is our initial velocity. That's what we're doing at. V of t is our velocity at any point based on time. And t is our time in seconds. We're always going time per second. Now g is roughly 32 feet a second if we're dealing in feet, or 9.8 meters a second squared if we're dealing in meters, or the metric unit. So it depends on what we're doing. So if we want to do it in feet, do it 32. If we want to do it in meters, do 9.8. V of 0 again is our initial velocity, and S of 0 is our initial height. So how far off the ground are we, or are we in a ditch, or whatever? All right. Hopefully that explains it. So again, S is the height of the object, V is the velocity of the object at any given moment. That's what the two functions represent. So we're going to do one problem with this, and we'll figure out from there, and then you on your homework and everything will have it. All right, as a promotion for the Houston Astros, downtown ballpark, competition is held to see who can throw a baseball the highest from the front row of the upper deck of seats, 83 feet above the field. The winner throws the ball with initial vertical velocity of 92 feet a second, and it lands on the infield grass. Find the maximum height of the baseball. All right. And then we also want to say how much time is the ball in the air. All right, so a couple of things we need to set up our equation here. Since we're doing height, we're going to use S. So we're going to think S of t. And that is equal to negative 1/2 g t squared plus v of 0t plus s of 0. We know that S of t is equal to negative 1/2 times g. Since we're doing it in feet, we want to use 32 times t squared, since we don't know time, plus initial velocity. Well, we know the initial velocity is 92 feet times t, plus initial height of 83. All right, well that gives us y equals negative 16 x squared, because we're going to replace x with t with x, plus 92x plus 83. At this point, guys, this is where we're going to use a calculator. So if you don't have a calculator, go ahead and get your calculator out. To do the calculator, all right, we're going to plug that in. And we are going to make sure that that equation is good, and we're going to find a couple things in it. One, we want to find the maximum height, right? To find the maximum height. So we need to find where is the maximum of this. So give me my calculator. All right. Give me the calculator here. Slide this over so we can see our equation. We'll go y equals, we got negative 16x squared plus 92x plus 83. Now, we can't just hit graph because it's pretty much not going to show up. If I hit graph, you're not going to see, you see something like this. That's it. We don't see the whole thing. So if you think about it, guys, we got an initial height of 83, right? And since we're going down, that's pretty much going to be our vertex. So we do kind of need to change our window. The X-min and X-max are pretty good scale, but I do need to kind of change my Y-min. Now, Y-min is 0, right? We're thinking on the ground is 0. Where it hits the infield is 0. So we really don't need to go that much below that. I'm pretty much going to just change that to negative point, or you know what, I'm just going to say negative 1. Now my max, that's going to be a little bit of a problem, all right? Now, you can set it, don't know how high it goes, let's say 150, and let's see graph. Oh, never mind. So 150 going to, I also want to change that. There's another way we can also do zoom fit. If you look at the bottom, number 0, zoom fit, sometimes that'll help us do it. And we actually do see the curvature, but we do want to do it again. So I'm going to go back to my window. I'm going to go back to zoom 6 and do standard. And I'm actually just going to change my window. It looks like it's between -1, which is fine with me, and 1, 2, 3, 4, 5, 6, 7. So if my window, I'm going to just leave the X alone. Again, I'm going to change my Y to -1. And I'm just going to do trial and error. I'm going to do the scale. I'm going to actually move that to 10. But trial and error, okay, let's say I did 150, it didn't show up. Let me do 200 in graph. Oh, still don't see it. So let me do it one more time. I'm going to change it to 250. I'm pretty sure we're going to be able to see it at this point. 250, there we go. And we see that at time 0, right, we were at 83, we threw it way up in the air, and then it comes crashing down. So we need to find what's the maximum height. So we just do maximum height. Do second, trace. Number 4, maximum. Tells me left bound, right bound. So left bound. Pick a spot to the left of the max. Hit enter. Pick a spot to the right of the max. Hit enter. And then just pick a spot somewhere in between. Hit enter again. And you'll see that my maximum occurs, or maximum height is 215 feet. 215 point, sorry. 215 and 0.25 feet. All right, 215 and 0.25 feet. All right, so at this point, we found our maximum height. Now the next question says, how much time is the ball in the air? Well, we basically want to find out how long does it take to hit the ground. Well, the ground is over here. Down here. This is where it hits the ground, way down here. So we actually need to find what point is that. We need to find our 0. So to do that, we're going to do the same thing. Second trace, and we're going to find the 0, 2. And it does the same thing, left bound, right bound. So I'm going to kind of scroll down here. Hopefully we'll get closer real quick. Oh, I went too far. Come back. There we go. Left bound, somewhere below it, right bound. Go back, hit enter. And we see that my 0 is at 6.54. So that's how long is it here? 6.54 seconds. So taking that, all right, so on your calculator, so none of this I'm going to make you do by hand for the most part. On your calculator, all right, if you're finding the initial height, you want to find the max on this one. To find how long it's in the air, you want to see where does it hit the ground on the other side. And you could also say how long does it take to get to its maximum height, which you would say is your x-coordinate length. So remember in this, when we're doing the graph, your x's are your seconds, and your y values is your height. And that makes sense, because again, t is my x, t is seconds. All right. If you have any questions, please come see me, but that is the lesson for today.